Good afternoon, everyone. It's good to see you, some of the students, and Dr. Zhang. Thank you for attending. I'm going to share the screen. Just a minute. Right. Well, I'm glad to be here to present some of my work recently on the application of machine learning in large-scale assessment data analysis. So just to use a couple of slides to talk about the research I've done before. So before I switched interest in the data science, I used to focus on measurement and statistics. For example, for measurement, I've done studies using Monte Carlo simulation to study the differential item functioning, which is an important part for test development and validation. So it's a common scenario is when students are from different groups, such as different gender groups, but they have same ability level. They may have different chance of getting the item correctly. So analyzing the diff can help ensure the test fairness and the validity in assessment. So for this study, I did a simulation study by using the mixture IRT models to check the latent group structures that may exist within the population. So the purpose of that study was to evaluate the performance of mixture IRT models in detecting diff across latent groups. And the study examined the effect of covariance and estimation methods on the detection of two types of diff. So like I said, for that study, I used the Monte Carlo simulation and the mixture 2PL IRT models. Several factors were manipulated and the model performance were evaluated. So that study provided insights and practical recommendations on using the mixture IRT models for diff analysis. And other studies I've done within the scope of measurement my interest was in equating. So for example, I compared different equating methods, including linear and nonlinear approaches, such as Tucker, Levine observed score method, frequency estimation method, IRT-based method. So basically, that was a more methodological study checking, again, it was using the simulated dataset and manipulated test form difficulties and the degree of group ability differences. So the goal of that study was to extend the literature by comparing different linear and nonlinear equating models to help providing a guidance for the practitioners of using different equating method under when the assumptions were violated. And then I also have done some like using the empirical studies. Using empirical data. For example, a study I've done was using the TOEFL test scores because TOEFL was widely used by the US colleges and universities to measure English language proficiency. And the scores were are usually required for international applicants seeking admission to graduate programs. So previous research suggests the relationship between TOEFL score and academic performance may vary across academic disciplines. The data was used was from the Office of Institutional Research at WMU, and the data included TOEFL scores over a GPA, including about 170 international students. For that study, well, it was an empirical data set, and I fitted a series of structural equation models to examine the mediation effect of self-efficacy and academic stress. And then the factors were evaluated in relation to the predictive validity of TOEFL scores. So that study, the purpose was to investigate the mediation effect that influenced the predictive validity of scores, of TOEFL scores. And then for statistics, I've done some studies such as the first one I've done, well, that was a few years ago, was on the pathway that mediate the gender mindset and motivation. So mindset and motivation are shown to play a critical role in early career exploration among youth. So females are generally less motivated to pursue STEM careers than males. So for that study, we used a large sample from 1,400 high school students in grade 9 to 12 from 4 public schools in West Pennsylvania. And the measurement, we measured their academic achievement and career aspirations, their mindset and motivational beliefs, and their expectancy, beliefs, task value, and perceived cost for pursuing the STEM career. The methodology for the study was based on the mediation analysis with 4 mediators to examine the pathways linking the mindset, motivation, and outcomes. So I'm going to skip some findings from the study. And then the other study I've done, the next 2 studies I've done was more methodological. For example, I compared the different clustering method in discovering the hidden group patterns. Because in our educational research, we often faced an issue that is to explore the data without predefined hypothesis. So a lot of times our educational researchers attempt to discover underlying structures naturally emerging from the data. For example, some research questions maybe, are there specific characteristics that identify an effective teacher? What patterns exist in how students use self-tutorial learning environment, etc. So that study focused on comparing traditional clustering methods with latent class analysis. The goal was to determine which method provide better identities of meaningful hidden structures in the educational dataset. And another methodological study I've done was to compare the software packages that handles different sampling weights. Because most of our standard used statistical software packages, they perform calculations based on the ideal assumptions that data from a simple random sample. However, it is nearly impossible to achieve a pure random sample when conducting the survey due to the cost and other logistics in gathering data. So because most large-scale survey samples involve stratification or multi-stage sampling, the appropriate analysis of survey sample data needs to take into account the nature of the sampling techniques. So for this methodological study, I investigated the quantitative differences between the commonly used statistical software analyzing the survey sample data such as SAS, M+, and R. They were compared. And in the last few years, my research interest gradually switched to the topics within the data science. So Before I continue on with talking about the studies I've done, I want to spend some time to briefly talk about machine learning. What is machine learning for folks who do not have much background in the area? So machine learning is a branch of artificial intelligence in which computers learn patterns from the data so they can make predictions or make decisions without being explicitly programmed with detailed rules. So in simple terms, instead of writing step-by-step instructions for every situation, we provide the computer with data, and it learns the patterns within the data to make predictions about the new information. So machine learning approaches are commonly categorized based on how the data are labeled. There are three main categories under the machine learning approaches. So first one, we call it supervised learning. So which is when the model is trained using labeled data, where the correct outcome is known. Then the goal is to learn a relationship between the input variables and the target outcome. The next category, we call it unsupervised learning. So unsupervised learning is when the model works with unlabeled data and attempts to discover the hidden structures or patterns within the data. And then the last one, we call it semi-supervised learning, is when the model uses a combination of labeled and unlabeled data to improve learning performance. So one key feature of machine learning is its ability to learn from existing data and use that information to make predictions or decisions about the future data. So machine learning has been widely used in many fields, such as a stock market, prediction, medical diagnosis, recommender systems, right? Everybody shops on Amazon, and then once you have some purchase history, and then the system will automatically send related items to you. That's what we call the recommender systems. It was all based on the previous data the machine learns from the users. So, and also educational technology. So the first study I've done was several years ago, which was when I started to become interested in how popular machine learning has been used within the educational field, in particular in predicting student performance. So, and this was a review study. So we reviewed, so the study mainly was focusing on examining the use of machine learning algorithms in predicting student academic performance. And then we selected a wide range of papers across different disciplines. And the purpose was to examine to what extent machine learning algorithms have been used. And then the review followed the preferred reporting items for systematic reviews and meta-analysis, the PRISMA, the commonly used PRISMA framework. And the goal was to provide a roadmap for future researchers in the field of educational machine learning. So we used the ProQuest research library to search for the articles by using the key terms of student performance and the machine learning algorithms. And then the search targeted peer-reviewed journal articles written in English from 2017 to 2022, including 310 studies. And we applied some inclusion selection criteria, such as the study has to be empirical in nature. The study has to use a real-world data set. The study addresses educational questions in K-12 or higher ed. And the machine learning algorithm were used as the main analytical techniques. And the study included individual measures, such as demographic, academic, or behavioral measurements. And then we created this coding scheme, including 10 categories that was modified from previous research. So the coding scheme include research purpose, general information, individual difference, learning outcome, missing data, feature selection technique, validation of algorithm, the machine learning algorithm used, the evaluation of algorithm and machine learning with highest accuracy. So next slide shows the 10 categories with the specific subcategories per each. And as you can see here. Now I'm just going to show you a few, some of the results that we discovered. For example, we found that the top 3 purposes of using machine learning algorithm in predicting student performance was, of course, prediction, because yeah, that's the key area we're interested in. In addition to that, diagnosis recommendations were also used as intervention recommendation. And we also found most of the reviewed studies focused on student learning performance, and as an outcome, this was expected, as one of the key research terms was student performance. It was noticed that 10 of the studies involved a student dropout from schools. It was known that student academic performance is one of the strongest predictors of dropout. So altogether, it can be said that the main interest of the reviewed studies was to either prevent students from dropping out or improve their learning outcomes. We also found overall the machine learning algorithm used in the order from the most to least used were the neural networks, decision tree, support vector machines, random forest, regression, naive Bayes, and a KNN. Yeah, so the next slide, we visualized the algorithm evaluation indices used in the reviewed studies. So we found that in classification problems, the most frequently used model fit indices for evaluating machine learning algorithm classifiers are accuracy, precision, recall/sensitivity, F-score, OC, the area under curve, AUC, and the receiver operating characteristic, ROC. There were some overlaps in the numbers and the types of evaluation techniques used in the reviewed articles. But it was found that the accuracy was the most often used evaluation measure, followed by precision and recall. The category of others contained 16 regression studies that used the indices of such as R-square, mean square error, root mean square error, and the mean absolute error. And the last, when we check the performance of the machine learning algorithm that was used in the reviewed articles, we try to find out what machine learning methods tend to have the best performance prediction. So because it was already known that the performance of the machine learning methods depends on a lot of factors, such as dataset size, feature types, noise level, and problem complexity. And it can be seen from the figure that neural network was the most frequently used machine learning algorithm and had the highest accuracy among the studies we reviewed. The next highest accuracy was found in random forest, followed by the KNN, support vector machines, and naive Bayes, which occurred in approximately equal number of studies. And this discovery was consistent with the general ranking in many studies. Often we'll see something like neural network, random forest, support vector machine usually have higher performance compared with other machine learning methods. And then the next study that I looked at was to predict student math self-efficacy by comparing the traditionally used linear model, which is our multiple linear regression, with machine learning method. Again, this is try to look at whether how the methods differ in terms of their prediction, but this time I'm using the student math self-efficacy. So self-efficacy usually refers to students' belief about their ability to perform specific tasks or achieve goals. It is a very important psychological factor that influence students' learning experiences and overall well-being. So students with higher self-efficacy tend to perform better in school, demonstrate greater persistence, and use more effective learning strategies regardless of their initial ability level. Research examining the factors associated with math self-efficacy remained limited, particularly studies using large-scale national data sets. So the purpose of this study was to develop predictive models to identify the key characteristics that strongly contribute to student math efficacy, and also evaluate the effectiveness of regression-based machine learning methods for analyzing large-scale educational data. And last, provide insights that may help educators and policymakers better understand the factors influencing students' confidence in math learning. So for this purpose, we used the PISA 2012 dataset, and then it all came from the US sample, so including about 6,000 students, half and half, almost half and half, 2 gender groups. And altogether, we identified, in terms of previous research, we identified 40 predictors, including student, parent, teacher, and school information, such as family background, parent education, student experience with learning math, student math, self-beliefs, math teacher support, school activities related to math, schools, math policies, etc. And then the only outcome variable we use is math self-efficacy, which is a single variable in the dataset. And then we used 4 predictive models. We compared the performance. Those models we used, including traditionally used linear model, which is the ordinary least square regression model, and then 2 additional machine learning predictive models called rigid regression, lasso regression, and then elastic net. So for the ordinary least squares model is one of the most commonly used regression models for prediction, and it has been used a lot by education researchers. So basically, the model estimates regression coefficients by minimizing the sum of squared differences between observed and predicted values. And previous research on math self-efficacy has primary belief on the OLS regression models, but there are some limitations many researchers missed. For example, with OLS models, when there are too many predictors are included, the model may capture noise rather than the true relationship, and reduce its ability to generalize to the new data. So we call this overfitting. Another limitation of a use that's traditional regression model is when we have large-scale data set. such as the one that was used here. The traditional regression model may perform poorly when analyzing dataset with large number of participants and predictors, and they may experience convergence issues when estimating many parameters. And also the OLS models rely on assumptions such as linearity and low multicollinearity. So with many predictors, it's very difficult to ensure that the assumptions are met because the relationship we try to discover may become complex and nonlinear. So if we force them into the linear form, it may distort the true relationship. So due to those limitations that OLS regression models have, we tried 3 alternatives. So those 3 techniques are called regularized regression. They can be used as potential solutions to address those limitations. So based on this, we use the 3 regularized regression models: rigid regression, lasso, and elastic net. So ridge, lasso, and elastic net, they originate from traditional statistical models, but are commonly considered machine learning methods. They are classified as regularized linear models used in supervised learning, particular for regression tasks. So the 3 models function as machine learning methods because they learn patterns from the data. They estimate parameters using training data, and they apply regularization to improve predictive performance and reduce overfitting. And in general, we discovered that all 4 regression models, they performed very similar in predicting students' math self-efficacy. So the evaluation indices we used include the model accuracy indices such as R-squared, AICPSE, RMSE, cross-validation press. But we saw the lasso and elastic net perform slightly better than the traditional method and rigid regression. And by using the 4 models, we also identified the top 10 significant predictors identified in each model, and we rank their importance in terms of the, there are some importance values. So the next slide showed, so each row represents a model and each column represents the 10 factors. So as we can see, it was found that self-concept emerged constantly as the most important predictor in math self-efficacy in all models. The lasso regression and the elastic net both identified math anxiety and math behaviors to be one of the most important predictors. It was also found that the ranking of the variable importance was more consistent between the lasso and the elastic net. However, there's a large discrepancy regarding the importance of math intentions and the sense of belonging to school among the 4 models. Okay, the next study I would like to talk about was a recent study that I collaborated with Department of Consumer Science, Food and Consumer Science. So the study we looked at to identify the diabetes predictive factors with machine learning method. So this was a study that we used non-educational data set. So The basic background for the study is we know that it was estimated about 11.6% of the US population has diabetes, including both diagnosed and undiagnosed cases from the CDC data 2024. And among those diagnoses, about like 90% of diabetes cases are type 2 diabetes. And the high prevalence of diabetes places a significant burden on the healthcare system. So there were risk factors that have been identified for type 2 diabetes are modifiable, such as unhealthy diet, lifestyle, smoking, high blood pressure, overweight, obesity, sleep problems, SES, such as low income and low levels of education. And it was found machine learning has been used in diabetes prediction. And then for this study, we used 3 machine learning methods, including neural networks, random forest, and support vector machines. They have been shown having the strong potential for predicting diabetes risk and identifying high-risk individuals. So the goal for the study was to develop predictive models for diabetes identification using the machine learning techniques. And the findings aimed to provide empirical evidence to support federal and state governments in improving public health management and the policy development. So for this study, we use a secondary data set, which is called the Behavioral Risk Factor Surveillance System. So this is a survey system and is the largest health survey system in the world, conducted by the US Center for Disease Control and Prevention, the CDC. So each year, the BRFSS, they collect health-related from more than 400,000 adults in the US. So we chose this data set because it has a full representation of the population in the US and it's large scale. So the data set we used were the 2022 data. By that time, the newest data set was not released yet. So we used 2022 data set, which included about 445,000 participants and more than 300 variables, which covers a wide range of information, such as the demographic characteristics, lifestyle behaviors, health conditions, and the risk factors. So the large sample size and comprehensive variables provide us a strong foundation for identifying factors associated with diabetes. And the dataset also supports the development of robust predictive models using the machine learning techniques. So the data analysis followed how many steps? Yeah, followed several steps. So first of all, we did some feature selection. So there was one target variable, or we call it outcome variable. So it's just a categorical variable. So it's 3 categories. So ever told you had diabetes? Yes, no, and no pre-diabetes or borderline diabetes. So that's 3 categories. And we identified about 120 features associated with diabetes diagnosis, including their demographic, lifestyle, and health indicators. They were all dumped into the model. Well, not yet. So we identified a large number of factors that are related. So the next step, I did some missing value. I handled some missing value. So because it's a complex data set, so we found a large missing values. So for the features or the variables with more than 90% missing values, I exclude them from analysis. And the missing data in categorical features were addressed using multiple imputations, while I used the medium imputation to the continuous features. And then we ended up with a final data set with about 147,000 participants and 90 features, which seems a little bit more manageable. And then the actual data analysis, those are the pre-processing of data. And the actual data analysis was done by using the 2 steps. So the first step, I used a technique called factor analysis for mixed data, FAMD, because the dataset contains a large number of features. So factor analysis for mixed data was used to reduce the dimensionality of the dataset. Yeah, because it's going to be very difficult to interpret if we fit all features in a single model. So I want to reduce the dimension to extract the factors. So basically this technique is a method that extends the principal component analysis, the PCA, to handle both continuous and categorical variables simultaneously. So that's why it's called mixed data. So this approach allows the analysis to retain the most important information while reducing the complexity of the dataset. So basically it allows us to extract the factors in the dataset. And then using this, I identified the optimal number of factors using the square plot and the cumulative variance explained. And then the analysis was done using the Prince library in Python. And then after this, after the factors were extracted, and then I import the factors into the 3 machine learning models. Well, so the neural network, random forest, and the support vector machine were used. So neural network is a machine learning model inspired by how our human brain works. The neural network consists of the layers of connected neurons. So that process input data and learn complex patterns. So each connection has a weight. So neural networks are powerful for modeling non-linear relationships and are widely used in tasks such as image recognition and speech processing. So in particular, for this study, I used the feed-forward neural network by using the TensorFlow in Python for multi-class classification. And the next machine learning method I used was the random forest. So the random forest is a method that builds many decision trees and combines their predictions. So each tree is trained on a random subset of the data and features, which helps reduce overfitting. The final prediction is typically made by the majority voting or averaging. So random forests are popular because they are accurate, robust to noise, and work well with many types of data. So in particular, the random forest classifier was used uses skitlearn in Python. The model was fine-tuned by adjusting hyperparameters such as the number of trees, the maximum depths of the trees, and by using the grid search cross-validation to perform an exhaustive search over a range of values to find the best combination of hyperparameters. So those are some technical steps that was handled under the model. And then the last method I used is the support vector machine, SVM. So the SVM is a machine learning algorithm used for classification and regression. It works by finding the best boundary or hyperplane that separates different classes in data while maximizing the margin between them. And the SVM can also use kernel functions to handle complex nonlinear relationships by mapping data into higher dimensional space. So I use this SVM classifier and phi2 by adjusting the regularization parameters, kernel type, and gamma parameter. And the final model was evaluated by using some performance metrics, such as accuracy, precision, recall, and F1 score. So so by using factor analysis for mixed data, what was found, so 7 factors or components were identified. And the table showed how many items are loaded on each factor. And so the first factor that was identified is called general health and the SES. This is defined by features such as general health, physical health status, difficulty concentrating or remembering, employment status, physical limitation, educational level, and income level. So there are 11 items. The second factor is called smoking behavior and smoking history. And then I'm just going to skip reading the factor names. But as you can see here, we successfully identified items. They're all loaded on the 7 components by referring to the script plot. So we just choose the ones that appears the most significant on the script plot. And then after the factors were determined, it is important for us to assess the internal consistency of the features that load onto each factor to ensure the reliability in factor identification. So we use this Cronbach alpha to evaluate how well a set of features align with a single factor. So as is shown here, the Cronbach alpha values range from 0.84 to 0.97, suggesting the items defining each factors are consistent and reliable. And then the model performance metrics, we use accuracy, precision, recall, and F1 score for each of the models. So the metrics are commonly used in classification tasks, especially when dealing with imbalanced classes. So as we can see, all 3 models consistently achieved a diabetes prediction accuracy of about 0.89. In particular, the neural networks classifier demonstrated well-balanced performance across the key metrics, including the 3 indices. But as you can see, there's very small differences across models. And the 7 identified factors were also ranked in terms of their importance in predicting diabetes. So the strongest predictor across all 3 classifiers were the mental health and the social support, healthcare access, and the preventive care, general health, and SES, underscoring their critical roles in diabetes prediction. So again, this is a large-scale health data set. So next study that was done last year, again, was the one I did during my sabbatical. So that study was a collaboration study with the National Commission on Certification of Physician Assistants. So NCCPA is the only certifying organization for physician assistants in the US. It provides certification programs that reflect standards for clinical knowledge, clinical reasoning, and other medical skills and professional behaviors required upon entering into practice and throughout the career of the PAs. So they offer 2 types of exams. So when graduates exit the school, they have to take the certification exam, and then they have to get they have to be recertified after a certain number of years. So the recertification exam measures the core medical knowledge that is relevant for all clinical practicing PAs. So, for example, they are eligible to take the recertification exam, we call it PENRE, in the 9th or the 10th year of their certification maintenance cycle. And then starting in 2023, in addition to this traditional used recertification exam, the NCCPA provide an alternative option to allow the PAs take a test called Physician Assistant National Recertifying Exam Longitudinal Assessment. So this assessment is unlike the traditional recertification exam. It is longitudinal assessment taken over 12 quarters within 3-year period. That's about like, right, a quarter, 4 quarters per year, right? So within 3 years, this cycle. So for this study, our goal was to conduct a comprehensive analysis and forecast the trend in the this longitudinal assessment by using the time series analysis and to provide some empirical justification of using this longitudinal assessment to replace the traditional recertification exam. So there's some purposes that we try to achieve, right? So we want to analyze their longitudinal scores over the 3 years, and then to help the PA assess their medical, how effective the medical practices are, and help them identify the strengths and the weakness, and improve their knowledge to practice integration. And we also want to forecast their exam performance and what trend their performance displayed. So those would provide the NCCPA important information, and also provide medical policymakers with insights into potential challenges in recertification process, and also help optimize resource allocation to ensure the support systems for PA education and training, and support NCCPA empirical justification for applying this longitudinal assessment process. Because of some confidentiality issue, I cannot disclose the findings of the study, but I can briefly talk about the method. I think that may be relevant to folks who are interested in doing some forecasting by using time series analysis. I know this is a part of the machine learning, but was not usually offered in our EMR curriculum. So basically, we use this data set provided by NCCPA. So from the performance data for the PAs from 2023 onward, and we use the key variables such as the quarter of the assessment. So there has to be some time index. So there are 12 time index, and then we use their test scores, and then their score, their exam result, which is pass and fail. We also have some content area subscores and the demographic variables, and also PA's subspecialties, such as the ones where, pediatrics, dermatology, hospital medicine, family medicine, right? So the different subspecialties. And the data pre-processing, we did some data cleaning, aggregation. So basically data was aggregated to quarterly statistics, and it did some stationary assessment and transformation. So with the time series analysis, we have to do some initial analysis to check whether there's any temporal patterns in participants' performance, such as we see any systematic changes across quarters within which year, and then we fit this time series models we call it autoregressive integrated moving average, ARIMA. So if any of you are interested in time series, ARIMA is one of the main models we use for analyze the time series data. And we modeled the parameters. The parameters were selected based on the diagnostic statistics such as ASC, BSC. And also, after the modeling, we use some smoothing technique, which is to ensure that we can capture the trends and the potential system patterns. Lastly, the selected models were used to provide a short-term forecast of the quarterly mean scores on the test and the predict performance patterns across specialties and demographic peer groups. And then again, the prediction accuracy was evaluated with different metrics, such as RMSE and MEA. So those were some studies to give you some flavor about the machine learning use in a large-scale assessment dataset. As you can see, some of them were educational related and some are not. So there were some ongoing studies I'm working on. So one of it is I want to look at the explainable AI for predicting and understanding math achievement. My focal content area is math learning, so I'm using the math achievement in PISA 2018. So for this study, I would like to understand the multifaceted factors that influence student math performance. So using the explainable AI techniques to PISA 2018 data is with the goal of better understanding the factors that predict math achievement and also discover the key predictors across diverse national contexts. So I'm going to use the samples from different countries. So explainable AI, XAI, refers to the AI techniques that are not just predict, but also explain why the model made such a prediction. So the methodologies, I'm going to use 2018 data, possibly multi-country data. I haven't decided yet what countries I'm going to use, but the input feature would be more comprehensive, including the student behavior data, SES, teacher characteristics. And the means data needs to be handled by using multiple imputations. And the models. So models will, I'm going to use a base model, use the traditional and multiple linear regression as a base model, and to compare with the tree-based model, such as random forest and gradient boosting models. A neural network will be used, and the hybrid models, which combines the tree-based and neural network. And then, okay, I guess I need to skip this. The next study I'm planning on is to, well, this is a simulation-based study. It's more methodological. So basically, the idea for the study is try to solve the problem. Well, so in our survey data, for example, right, so we ask the student to respond to a categorical variable. And then, you know, the categorical outcomes are often very imbalanced, right? So I'm using the diabetes study as an example. So maybe most of people will select not diagnosed, right? So with this highly imbalanced data, how are the machine learning method functioned to the real class prediction? So this is a simulation study. And then I'm going to skip because we're running out of time. Methodology, that's the next study. I'm just wanna do it for fun. So I'm trying to design a chatbot for the courses I teach, the statistics, because it's been challenging for students who do not have any stat backgrounds of taking EMR 6450 and 6650. So I'm trying to design this chatbot to help students better understand that concepts, provide step-by-step explanations for problem solving. And I want it to be interactive and personalized that can help students based on their input. And then, so there's some technical design that I have in mind. There's some back end based on Python Hugging Face, which is a platform for language models. So, and input recognitions, what kind of input users are going to provide, whether it's problem solving, whether they're looking for test help or help clarification for concept, and there's some front-end design. That's this user interface. So thank you. Feel free to contact me if any of you is interested in any of the ongoing studies. Sorry, I used up all the time.
Thank you. So I'm going to stop recording now. And if anyone has any question, please feel free to jump in.
Yeah. So